So I'd like to do another exercise, a slightly bigger program. And this is a program to determine equality. So how does this work? Well, first of all, we already have something that does this. So for example, if I wanted to say equals A, B, that would work. And equals is just as powerful. That would return false. If I said equals A, that would return true. And equals is smart enough to work with lists as well. So if I said equals A, B, C, and A, B, C, this would this would return true. So this is going to return false. This is going to return true. And this is going to return true. Now, what if instead we replaced this equals with our own equals method? So we're going to call this is equal. All right. So could we write a method that achieved the same thing that equals did? Of course we can. Now, the caveat for this is you can't just say, all right, well, when you call is equal, just then call equals question mark to determine whether something is true or not. So we're going to have to use much more primitive functions in order to get this method to work. Now, one of the primitive functions that we can use is something called EQ. So EQ works like this. If I say EQ question mark, A, this will return true. If I say EQ question mark, A, B, this will return false. But EQ only works on atoms. It doesn't work on lists. So if I say EQ AB, AB, this will return invalid. It will fail. It'll actually be an, let's do it this way. It'll be an error. And that's because EQ only works on atoms. So we can use EQ in our program to determine equality, plus some other basic list checking functions, and we should be able to get this to work. Now, this program is a little bit bigger than some of the previous programs that we've written, and in order to figure out what we should write for code, I think a good thing to do would be to look at different cases. I often find that this, particularly for recursion, this can help me figure out what kind of recursive code I'm going to write, because often your solution to a problem using a functional programming language is a set of base cases and recursive cases. Of course, that makes total sense, right? You're going to have lots of base cases and recursive cases. So what you want to do is try to list those cases, and that will help you figure out what kind of programming you have to do. So let's look at some cases, all right? So here's a case. What if we have, so we'll say like case number 1. We have 2 atoms, and they're equal. All right, so that would be something like this, is equal A. So we definitely have to handle that case. That's true. That's going to return true. I guess we'll say true here. True. That's going to return true. Let's look at another case. Case number 2. We could have 2 atoms, and they're not equal. So we'd have is equal A, B. So this is going to return false. Okay. How about, let's see if we can think of some other cases. So this kind of handles when we have atoms. We might have lists, right? We could have two lists. So how about this? Case number 3, two empty lists. All right, so we could have is equal one empty list and a second empty list. And that's going to be true. All right, let's see if we can come up with some other cases. Case 4, we could have an atom and a list. So an atom and a list. So we're saying is equal, here's my atom, and then here's my list. Okay, this is going to be false, right? An atom is not equal to a list. And also we could have a list and an atom. So just reverse case 4. Case 5, we could have a list and an atom. So is equal, here's my list, A, B, C, and here's my atom, A. This also returns false. So we've got two atoms that are equal, two atoms that are not equal. We've got two empty lists. We've got an atom and a list and an atom. What's the only case that we're missing? Case 6. We have a list and a list. All right, so, and we'll say that the lists are equal. So what's going to happen here? We're going to have is equal, and let's say we have A, and then B, C, and A, and then B, C. Okay, so we'll work on figuring case 6 out for a second, but I would just want to say that if you look at all of these cases, case 1, 2, 3, 4, and 5, these are all going to be base cases. There's no recursive anything about these. You know, you're checking to see if two atoms are equal. There's nothing recursive about that. You're checking to see if you have an atom and a list. There's nothing recursive about that. So they're base cases that would stop any kind of recursion that's happening. The case 6, though, case 6 is definitely going to be some kind of recursive case because we have no way directly without using equals question mark to compare one list to another list. So we're going to have to, what our strategy will be is to peel things off of the list and compare them. And if they're equal, great. Then peel the next thing off the list and see if that's equal, and just keep doing that and doing that and doing that until we have nothing less to process in the list. And as long as we keep finding things that are equal, that means we've got two equal lists. So let's just take a look at case 6. We'll expand it on the next page. All right, so here is case 6. And what we'll do is we'll say, okay, well, what we'll do is we'll say, let's imagine, I'm not sure exactly what the code's going to look like yet, But let's say that what we did here is we said is equal the first thing from the first list, the first thing from the second list, and we'll and that with is equal the rest of the list. So that was B, C, and B, C. All right, so this is going to evaluate to true, and then we can recursively evaluate the second is equal call. All right, and the second is equal call is going to do the following. It's going to turn into this. Is equal BC, BC, and is equal empty list. Okay, so we have to evaluate this before we evaluate this, but we know that's going to evaluate to true eventually, so that's good. All right, let's evaluate is equal this. So this is going to evaluate to is equal B, B, and the recursive call to is equal for whatever's left. So is equal C, C. And this is going to evaluate to true, so life is good there. And then this expression is going to evaluate to is equal C, C, and is equal empty list, empty list. All right, the is equal CC is going to evaluate to true. That's a base case because we're comparing two atoms. And this is equal empty list is also going to evaluate to true. So if we look at what we have true and true. That's going to return true. So this will evaluate to true. Now we have true and true. So this will return here and evaluate to true. This true gets ANDed with is equal empty list, which we said evaluated to true. So that's going to return a true here. And this true get evaluated, and that's going to return a true to here. And so the final rolling up of the recursive calls, we're going to end up with is equal the list A, B, C, and the list A with the list BC in it. Those two are gonna, those two lists are considered equal. So this is equal will return true. So case 6 is a little bit more involved than the other cases. All right, so now we have case 1 through 6, and we have just looked at how the recursive case 6 is going to work. And so it would make a lot of sense then to see if we can write the code to make this work. All right. So let's go over here and write the code for is equals. So we're going to define is equal, and it's going to take in two lists. And we're going to put a con statement in place. And we're going to consider each of the cases that we have. So let's go back and look at the cases that we have. So we have case 1, 2 atoms that are equal. So let's see if we can figure out if we've got 2 atoms that are equal. So in order to determine if something is an atom, you can't say, are you an atom? Well, maybe you can, but I don't know how you do the direct linking scheme, but I do know that you can ask if something is a list. So what we could do is we could say, if list 1 is not a list and list 2 is not a list, that means that they're atoms. So let's do that. So we're going to AND. So if list 1 is not a list, so if not list question mark list 1. Okay, that just said, is list 1 an atom, basically, right? Because if it's not a list, it's an atom. And the other thing is we're going to do the same thing for list 2. And list 2 is not an atom. All right, so if those two evaluate to true, it means that list 1 and list 2 are not atoms. So if they're atoms, we need to check to see if they're equal. That would take care of case 1. So EQ, not equals, because remember, we're using is equal to replace equal. So EQ, list 1, list 2. Okay. So this handles case 1 if list 1 and list 2 are not atoms and list 2 are not lists, that means they're atoms, and list 1 is equal to list 2, that handles case 1. So let's take back a look at case 1. So we've got the 2 atoms are equal checked off. So I'm going to put a little green here. All right, so case 1 is handled. Yay. And actually, case 2 is handled as well, if you think about it, because if the 2 atoms are not equal, then this statement, equal list 1, list 2, will return false. So if we're comparing A and B, that's going to return false. If list 1 is A and list 2 is B. If list 1 is, I don't know, I think list is probably not the right word to use here. Value 1. And value 2. Because sometimes it's a list and sometimes it's an atom. I like that much better. I'm sure you do too. Okay, so that handles our first case. Let's go back and take a look at our second case. Handle our second case. Great. Let's look at our third case. Do we have 2 empty lists? Well, that should be fairly easy to check. So, and empty value 1. Is value 1 an empty list? And value 2 is an empty list? Well, if that's true, we're going to return true. Okay, so that handles case 3. All right, so let's look at case 4. Do we have an atom and a list? All right, so we know how to check for atoms in a list. So do we have an atom that would be not list question mark value 1 and a list? So that would be list question mark value 2. And we're going to return false if that happens, right? Because if you have an atom and you have a list, that means that you've got an error. Okay. And then we have the reverse as well. If you have a list and an atom, that's also false. So let's do that. List value 1 and not list value 2. We're going to return false. Okay. All right, so let's go back to our code, our examples here, and we've taken care of case 4, an atom and a list, and we've taken care of case 5, a list and an atom. So we're left with dealing with case 6, which is a recursive evaluation. If we take a look at our code here, what we're going to do when we're in this situation is we're going to peel off the first item in the list and do an is equal on that, and do an and of that with the rest, and is equal on the rest of both lists. Okay? So we're going to do an and of the first item peeled off of both lists. So we're going to do first value 1. Oh, and but this isn't is equal. So is equal of the first thing off the list that's in value 1 and the first thing off the list that's in value 2. And that had better be equal. So hopefully that will it'll return true or false, whatever it is. And then we're going to follow that by a second recursive call to the rest of what's in value 1 and the rest of what's in value 2. Okay, and if those return true, then we'll return true. And finally, we're going to have an else. Okay, so let's just review this. So if the first thing we peel off the lists that value 1 has and the list that value 2 has is equal, that's good. And recursively, everything that we pull off from the other items in the list that's represented by value 1 and the list that's represented by value 2, if those are all equal, then we're going to return true. Otherwise, we're going to return false. Okay, and that ends our replacement for equals. All right, let's compile it, make sure we don't have any syntax errors, looking pretty good. And then let's give it a test. We'll test some of our cases here. So first, let's just test 2 atoms. All right, now let's test 2 atoms that aren't equal. All right, let's test an empty list. All right, let's test a list and an atom and a list. Great. Let's test an atom, a list and an atom. Awesome. And now the big kahuna. Let's test. Let's test a list. I'm going to use lowercase, ABC, and another list, ABC. Awesome. How about one where they're not equal? Awesome. And let's do a list inside a list. Oops, daisy. I didn't quite do that correctly. Awesome. So it looks like we have a really nice working is equal method.